Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Today, we're looking at this 2004 Honda Civic Hybrid. Customer complaint is that the vehicle intermittently stalls. Now, the customer did say that it takes about 20 to 30 minutes worth of driving before the vehicle will actually stall. Then after it stalls, he lets it sit for about 10 or 15 minutes and he's able to start it back up and it goes back to running normal. Now, a little bit of a backstory. The customer recently purchased the vehicle about 6 months ago. He got it really cheap because, of course, the vehicle needed a hybrid battery. So the first thing he did after purchasing the vehicle was have a new battery installed. But even after replacing the hybrid battery, he still continued to have issues. Now, another important piece of information, he recently took the vehicle to a repair shop to have them check it out. He said they put a scan tool on it. They found multiple codes. So the mechanic decided to clear all of the codes, told the customer to drive the vehicle until the check engine light came back so that they could see what codes came back. So anyways, the owner really didn't trust what they were doing. He wanted me to check it out. The vehicle really hasn't been driven since the codes were cleared, so that's probably the first thing I'm gonna do. I've got some errands to run, so I'm gonna take the vehicle for a test drive, see if we can get the check engine light to come on, and then get the scan tool on it. Anyways, with that being said, let's go ahead and get started. All right, guys, so I've been driving around now for about 45 minutes or so. Just had to run a few errands, and on the way back home, I could see that all of these lights came on in the instrument cluster. So if you look, we have the battery light, IMA, check engine lights on. We have this brake system light over here. We have the brake light on. And if you look at the D on the shifter indicator, it's flashing. So I'm not really sure what that indicates. I think the first thing we're gonna wanna do is go ahead and hook up a scan tool and see what codes we have. Now, as far as stalling, the vehicle has not stalled yet. It's still drivable. So I think the first thing I wanna do is take it back to the house, hook up a scan tool, and see if we have any codes. All right, guys, so we're looking at the scan tool. I'm gonna go ahead and click on Honda. Let's go ahead and do automatic selection. Read the VIN number. Let's hit OK. We have a 2007 Civic Hybrid. Let's go ahead and hit yes. USA. Now, before doing any code scan, I can tell you one thing that I don't like, and that's the fact that the engine is running right now. And if you look up here in the corner, you can see our system voltage is somewhere around 11.5 volts. So it doesn't look like the charging system is working right now. So that may be a big indicator or a big clue as to what's going on. Let's go ahead and hit diagnosis. Let's do an auto scan. This is going to scan all of the control units on the vehicle. Go ahead and hit OK. Looking at the engine computer, we have 18 faults. Looks like it's having trouble trying to scan the automatic transmission. It's been scanning for quite a while now, so let's see if it's able to complete it. As you can see, it skipped over the automatic transmission control module. Took a couple minutes, but it eventually just gave up. We've got nothing in the safety restraint. Now it's scanning the ABS. As you can see, we have no codes in the ABS module. As you can see, we have 5 faults in the body electrical, and we have 2 faults in the electric powertrain. Now, if you look, we have another 2 faults in the hydraulic booster. We'll let this thing finish scanning. All right, so now that we're done scanning, let's go ahead and hit report. This will give us an overview of all of the codes that are present. Again, we have the engine computer with 18 fault codes. So let's go ahead and start at the top. We have the first code is going to be a PO420, catalyst efficiency, below threshold. This thing probably needs a catalytic converter. Going on to the next code, we have a UO129. That's going to be an FCAN malfunction, PCM servo unit. So it looks like we have a communication code here. Then we also have a U0110. It's going to be lost communication with IMA motor control module. Next code is going to be a U0111. Lost communication with IMA battery control module. Next code, as you can see, lost communication with motor control module. Next code here is going to be EPP IMA CAN malfunction battery condition monitor module PCM motor control module. So you can see we have quite a few communication error codes. Next up, we have this PO60A. It's going to be PCM automatic transmission system internal control module malfunction. Then we have this PCM internal EPP CAN circuit malfunction, PCM TCM. Then we have this PCM internal FCAN circuit malfunction, PGM FI system to CVT system. You know what? I think looking at this, the rest of these are actually just temporary DTCs. I think at the top, these were the permanent ones, so I think it's just repeating itself. That's why we have so many codes. Again, if you look up here, you'll see permanent codes. We're at the start, and then here we have the temporary DTCs, so that's why we're showing so many different codes. Next up, we'll go to body electrical. And if you look here, we have 5 codes. Gauge control module, lost communication with the PCM. We have another one here, gauge control module, lost communication with advanced hydraulic booster unit. Another communication code. Then we have another code for the blower motor circuit, another code for the AC compressor, and then moving on to the electric powertrain, you can see we have 2 fault codes. First, we have a U0100. It's just telling me here, please refer to service manual, and another 100 code, and that's also telling me the same thing. So it's pretty evident that we have a problem with CAN communication between the different modules. But what I can tell you right now that I don't like is going to be the charging system voltage here. Again, like I said, the engine is running, and if you look up here, we're only showing 11.42 volts. So it definitely looks like we have a problem with the charging system. Now, whether or not it's possible that the charging system could be causing all of these communication codes, it's very likely. And I can tell you right now, if we have a low voltage problem, that could definitely cause a lot of communication issues between the modules. So before we try to go down this rabbit hole, I think the first thing we need to do is check the charging system. Well guys, before we go any further, let me show you something really interesting. So I shut the vehicle off, and then I turned it back on because I had to move it a little bit further up here in the driveway. And then I noticed that after restarting the vehicle, our charging system voltage is back up. So if you look here, you'll see 13.99 volts, 14 volts. So our charging system is back online when just a few seconds ago, this thing wasn't charging at all. So I'm curious as to why shutting the vehicle off and starting it back up all of a sudden made the charging system want to work again. All right guys, so moving under the hood. So you can see over here, we have our 12-volt battery. Now, of course, because this is a hybrid vehicle, there's also going to be the high voltage battery that's located behind the back seat. But this one here is going to be our 12-volt battery that feeds all of the accessories, the electronic controls on the vehicle. And of course, we want to see charging system voltage on this. So we're looking for something between 13 to 14 volts whenever the engine is running. Now, the other interesting thing about this vehicle is because it is a hybrid, it actually does not utilize an alternator. So if you look over here at the engine, you're not going to find a conventional alternator that's belt driven, nor are you going to find anything that resembles an alternator at all. This vehicle, because it is a hybrid, it's equipped with something called a DC to DC converter. And the job of that DC to DC converter is to basically take the 160 volt high voltage battery that's in the back seat. It's going to take that voltage, step it down to charging system voltage in order for this battery to charge and for all the electronics to run on the vehicle. So first things first, I wanted to do is I have this little battery tester here / multimeter. So we're going to connect it. Here's the negative lead. So let's go ahead and hook it up to the negative terminal. Then we have our positive terminal here. Just going to go ahead and hook it up. And if we look at the battery voltage, you can see it's pretty low, 12.3 volts. Let's go ahead and start this thing up and check our charging system voltage. Okay, so I've got the key right here. I'm going to go ahead and stick it into the ignition, start this thing up. Well, that was kind of interesting. I went to crank the engine over, and there was a delay before the engine actually started. And if you look up here on the instrument cluster, you can see the D is flashing on the shift indicator, and we have all our lights on. Let's see if I can replicate that. I'm going to go ahead and take the key back out. I'm going to put the key in and see if there's a delay when I crank this thing over. So the ignition is on. Now I'm going to go ahead and attempt to crank it. So you can see there's a delay there before the engine actually starts. And now that D is just flashing all the time. So I'm not really sure what that means. Let's go back under the hood and check the charging system voltage. Okay guys, so check this out. If we look at our charging system voltage, you can see we're only showing 11.8 volts. So it doesn't look like our charging system is charging at the moment. I'm not really sure what to think. I mean, at this point, it seems like our charging system is kind of intermittently coming and going. And at the same time, we have all of the lights illuminated on the instrument cluster. and that D is flashing on the shift indicator. And as far as my next step goes, I'm not even really 100% sure. I'm thinking I might just reconnect the scan tool, see if maybe we can clear the codes and see what comes back. Though I don't really think that's gonna help us. Maybe a better idea might be to use the scan tool to maybe look at the high voltage battery that's in the trunk. We can actually look at the individual voltages of each of the cells inside of the high voltage battery. I mean, that may give us an indication, because it is possible that if the high voltage battery that's in the trunk does not have sufficient voltage, then the DC to DC converter can't really do its job. And so the charging system is not gonna charge. And if you ask me, I'm pretty sure this is the reason why the vehicle is stalling. I'm pretty sure they're driving this thing for an extended period of time with the charging system not charging, and then eventually the battery just runs out and the engine stalls out. So anyways, I think at this point, I'm gonna go ahead and hook up the scan tool and see if we can get the data PIDs for the high voltage battery. All right guys, so we're back at the scan tool. And if you look up here, you'll see that we have several different options for the control modules that we wanna access. And the one we wanna concentrate on right now is gonna be the electric powertrain IMA. This is where we're gonna find the data PIDs that tell us the voltage of each of the individual cells inside of the high voltage battery. So we're gonna go ahead and click on this. Well, I have to use my mouse because my touchscreen is not working anymore. I still need to replace it, so I'm gonna use the mouse. Click on electric powertrain IMA, which I believe stands for integrated motor assist. That's basically what Honda calls this hybrid system. We're just waiting for this thing to communicate. And it's telling us that the tester is not communicating with the control unit. Now, our ignition is on. Let me try to start the vehicle up, see if that makes a difference. Again, guys, there's a delay whenever I go to crank the engine over. I'm not really sure what that's about, but anyway, let's go ahead and go back out. And let's try this again. Electric powertrain IMA. And again, guys, if you pay attention up here, you'll see that the charging system voltage is not charging. The other thing I can tell you that I don't like is that it really feels like this engine needs an engine mount really bad, because the whole car is just shaking. I mean, I can feel the dash and everything shaking, so I don't know if that has anything to do with it. And again, looking at this screen, guys, I mean, it's taking a while for it to try to communicate. And there we go, it's telling us again, tester not communicating with control unit. Now that's interesting, because I noticed that earlier when I did an automatic scan, it looked like we weren't communicating with the transmission control module, but we did show a couple codes for this IMA module. Let's go back and see if we're communicating with the transmission again. I kind of doubt that we are, because that's probably the reason that the D is flashing. Again, if you guys can see, the D is flashing on the instrument cluster, so it looks like we are communicating. Okay, let's go ahead and read codes. We're in the TCM now. Check this out. We're showing a bunch of communication codes. It says here, lost communication with brake system control module. It also shows IMA CAN malfunction, lost communication with brake system control module again. Well, actually, these codes are the same, so I keep getting fooled by this, but if you look, you'll see that these are permanent DTCs, and these are just the same DTCs when they were temporary, but right now they're showing permanent, so that's why we're showing two sets of the same codes. Don't let that confuse you guys. Anyways, I find it interesting that earlier we weren't communicating with the TCM. Now we are. This definitely looks to me like some intermittent communication problem, and if you ask me, I'm pretty sure it's going to be a wiring problem. And the reason I say that is because whenever we're having communication come and go, like we have in this case, it's usually because we have a loose wire or a loose connection, or maybe even a broken wire or a chafed wire that's touching something like a ground. I mean, I'm just saying that from experience. It could be that we have a bad module on the CAN communication system, and this bad module is causing erratic signals in the CAN communication line, and whenever that happens, it creates communication problems between all of the modules. So I mean, at this point, I think first things first, let's go ahead and take a look at the CAN system, and we can start by hooking up our lab scope to the data link connector on pins 6 and 14. Those are going to be designated for the CAN high and CAN low lines. We'll take a look at the waveform, and hopefully it'll tell us something. Okay guys, so I've got the lab scope hooked up. The vehicle is running. let me show you the setup that I have. If you look over here, we have this OBD2 breakout box. This is connected directly to the DLC connector down underneath the steering wheel over here. And if you look at this breakout box, you can see that I have my 2 channels on pins number 6 and pin number 14. And then I have my ground lead on the number 4 pin, which is going to be the chassis ground. And so now that we have this connected, we can look at the lab scope, take a look at the signal that we're showing. And I guess the important thing that I should mention is at the moment, the D is still flashing. So more than likely we don't have communication at the moment. But if we take a look at this waveform, let me turn off the light from my camera so we can get rid of this glare. Okay guys, so looking at this waveform, if you guys know what you're looking for, then you can see that this waveform actually looks pretty normal. And just in case you guys don't know what to look for when we're looking at a CAN signal, we're basically looking for a couple different things. Number one, we want to see that the voltage is somewhere between 2 and 3 volts on both channels. And the other thing we want to see is that these 2 signals basically mirror each other. And what I mean by that is that when this channel signal goes high, this channel signal is going to go low. So it's basically like a flip-flop of each other. So let me go ahead and pause the screen and take a look at the signal here. You'll see that this channel 1, whenever the signal is going high, the channel 2 signal is going low, and we have this mirroring effect. This is exactly what you want to see. This is what a good signal looks like. And this is also a good indication that our problem most likely is not in the CAN network system. Now, what we can also look for, if we go ahead and put this back to live data, we can also look for any type of glitches or dropouts. So if you watch this signal and you see a bunch of hash or something crazy happening, then that's an indication that we have a problem in the signal. But at this point, I've been looking at this thing for quite a while now, and I have not seen any glitches or any dropouts in the signal. So far, everything looks good. Okay, so once again, looking at the scan tool, I've got it connected. And the nice thing about this breakout box is that it has another OBD2 plug here so that we can simultaneously plug in the scan tool and have this breakout box plugged into the DLC connector. So again, we're gonna look at the scan tool. I'm gonna try to communicate with the electric powertrain IMA. I'm gonna go ahead and click on it. And again, if you take a look at the CAN signal, you can see that we have a nice clean CAN signal. We're just gonna pay attention to see if this thing is gonna communicate or not. And as you guys can see, our tester is not communicating with the control unit. And again, our CAN signal looks nice and clean. So to me, this doesn't look like an issue with the CAN bus network system. To me, this looks like more of an issue with either a bad control module or a module that's missing a power or a ground. Okay, so hopefully you guys are following along. Hopefully you guys understand my thought process and why we're going in the direction that we're going. So basically, we know that we have a control module that is not communicating. In this case, it's the IMA or electric powertrain control module, which by the way, on this particular vehicle is called the BCM. Not to be mistaken with the body control module. BCM stands for battery conditioning module or battery control module. Once again, we know we don't have communication with it. We've already looked at the CAN bus communication system. Everything there looks okay. So before we call a bad module, we always want to check the main powers and the main grounds to the module. So hopefully you guys are following along. Hopefully that makes sense. Let's move on to the next step. Okay guys, so we're here at the computer. I've got the wiring diagram pulled up for the IMA circuit. IMA stands for Integrated Motor Assist. And this wiring diagram is going to cover everything that's involved in the system, everything including the high voltage battery, the DC to DC converter, the battery conditioning module, and all of the associated wiring. So with that being said, if we take a look at the wiring diagram, you see this big rectangular box here at the top. This is going to be what's called the junction board. Now the junction board is attached to the side of the high voltage battery, which is in this dotted area right here, this box. It's going to be the high voltage battery. Now, if you look inside of this junction board, you're going to find several relays and sensors, switches, and these are all going to be used to both monitor and to control the high voltage battery. So first things first, if you look over here, you'll see the battery module switch. This is going to be the big switch that's behind the seat that you use to disconnect and disable the high voltage battery. So if you look at the way this switch works to disable the system, if you look down here, you'll see there's a battery pack, and over here, another battery pack. Well, these are actually several packs inside of one, but if you look over here, you'll see it's labeled positive, and over here it's labeled negative. Now, if you pay attention to the 2 big orange wires that are coming out of the high voltage battery or the junction board, you'll see that one of them is for a positive and the other one's for a negative. So if you follow this positive wire here, you'll see it goes into the junction board. It's going to go into these battery packs right here. You're going to see it has a connection coming out through here, and then that connection goes to the battery module switch. When this switch is closed, we have a path to ground. So if we follow this through this 100 amp fuse, you'll see that it goes through this battery pack out through this side over here. Now this is going to be the ground, and if you follow this through the relays, you'll see it goes through the battery current sensor. So all of the current for the high voltage battery is going to travel through the battery current sensor. It's going to come out on this wire here and come out as this orange wire here. So again, we have a positive and a negative, and the way you disable this battery is by opening the switch right here, and that's what severs its path to ground. So again, if you look down here, you'll see this is the high voltage battery pack, and you'll see over here we have some temperature sensors. These are battery temperature sensors, and they have wires that come out and go to the BCM that's located right over here. Now, when I say BCM, again, not to be confused with the body control module. If you look right over here, you'll see BCM module. BCM stands for battery conditioning module or battery control module. So that's what this box here on the left-hand side is, and this is what we're having trouble communicating with. Now, I don't think we need to get into details of how the overall system works. If we scroll up and we look over here at the high voltage battery, once again, you're gonna see a bunch of wires coming out. Now, what these wires are, they're actually direct connections to the battery packs. These are used for the battery conditioning module to monitor the voltages of these battery packs. So if we highlight these wires, any of them, and we follow them down, you'll see that they're gonna go back over to the battery conditioning module. So if you look over here, you can actually see that they're labeled and numbered to correlate with the battery packs. So if you look over here, you'll see VHB and the number next to it, 10, 12, 4, 2. That's going to indicate which battery pack that terminal is monitoring. So anyways, back to the problem that we have at hand. We are dealing with the communication issue with this BCM. Now, I talk about this a lot. You'll know if you watch any of my other videos where we're dealing with no communication to pretty much any type of computer that's on the vehicle, whether it be an ECM or a BCM or a TCM, it doesn't matter. The principle is the same. In order for that computer module to communicate, it has to have its powers and grounds. In much the same way that the computer at your house, just like this desktop we're looking at, it will not power up until I plug it into the wall. It's the same thing with the computer on a vehicle. So anyways, now that we have the wiring diagram pulled up, we can look at all of these individual connections to this module, and what we need to try to do is we need to try to determine which of these pins is for a main power or a main ground. And again, you can have several powers and grounds on a single computer. It doesn't just have to be one power and one ground. Sometimes you can have multiple powers and grounds. Sometimes you can have a power that's a power all the time straight from the battery, and then you have another power that's an ignition power, which only gets power when you turn the key on. So anyways, with that being said, let's go ahead and get started by looking at this BCM and trying to identify what our main powers and grounds are. So I'm just going to zoom in a little bit over here. Okay, so hopefully you guys can read that. Let's go ahead and start at the top. As you can see, CAN H, that's going to be a CAN communication line. We're not going to worry about that. But if you look right underneath, pins A2 and A3 are designated IGA1 and IGA2. I'm pretty sure these are ignition voltage feeds. So I'm going to go ahead and highlight those two, pins 2 and pin 3. Now what we could do is follow these two wires back and find out where these ignition voltage feeds come from. So if you look at these two red wires, they're going to continue on the next page as number 1 and number 2. So we're going to go ahead and move over to the next page. Okay, so we're on page number 2. Now if you look down over here, you'll see number 1 and number 2. This is going to be the continuation of our two pink wires. And if you look over here, follow them up, you'll see that they go to this junction connector right over here. And it says here it's behind the IPU lid. Now, if I'm not mistaken, I believe this is the cover behind the seat for the high voltage battery. Now, if we follow the pink wire out this way, you'll see that it goes to this MCM relay number 1, which is also behind the IPU lid. And if you take a look at this relay here, you'll see that it's normally in an open state. So what that means is with the ignition off, this relay is going to be open, and with the ignition on, this relay is going to close, and that's going to allow current to flow from here down through the relay. So if we follow this up on this green and yellow wire, you'll see that it comes from fuse number 62, which is a 7.5 amp fuse that's located in the auxiliary underhood fuse box, which is on the left side of the engine compartment. Now, if we scroll back down and we take a look at this green and yellow wire, you'll see that this is for the control side of the relay. And if you look at this, you'll see both the control side and the switching side of the relay share the same power feed from that fuse. Now, if we look at how this relay is controlled, you'll see that this is the control side, and on this orange wire, this is going to be the circuit that grounds this relay in order for this switch to close. So let's go ahead and follow this orange wire. You'll see it goes to number 6 over here on the first page. So let's go ahead and move over to the first page. And if we look over here, you'll see number 6. I went ahead and highlighted it. And if you follow that wire, you'll see it goes back to the BCM. And if you look closely, you'll see the description says ignition hold. I believe that's what that stands for. It says IGHLD, and right underneath it, it says IGHLD number 2. And that's a light green wire. So I bet you if we highlight this wire, number 2, that's probably going to go to the other relay. So again, if we look over here, that green wire is going to be number 7, continues on the next page. Let me zoom in here. We'll highlight number 7, and if we follow it up, you'll see that it goes to this MCM relay number 2, which is also located behind the IPU lid. And again, if we highlight our 2 pink wires that are coming from the BCM, the ignition voltage feeds, they connect to this junction connector here, and you'll see that it also gets split out this way. So if we highlight this here, you'll see that it feeds the power for the control side of the MCM2 relay. So what that means is that this MCM1 relay provides the power for the control side of the MCM2 relay. Now, going back to the first page, well, before we do that, we understand now that our 2 pink wires get their power from this MCM1 relay that gets its power from that fuse. So now that we know that, we can go ahead and move back to page 1, and let's continue looking for voltage feeds or grounds. So if we look over here, again, we have our IG1 and IG2, both of our ignition feeds on pin A2 and A3. Now, if we look underneath it, you'll see something labeled VBU. I'm not sure what that means. That may be voltage battery. So let's go ahead and highlight that one. If I zoom out, you can see that over here it turns into number 3. So we'll go to number 3 on the next page. It's this white wire right here. And if you follow it up, you'll see that it comes from this MICU module that's located inside the under dash fuse relay box. Now, if you follow this up, you'll see it gets its power from this fuse number 23, which is located in the underhood fuse box. Now, looking at this control module here, I'm not really sure if this is a voltage all the time at the computer, or if this MICU module controls when to send voltage on this wire here. So this may or may not be a main voltage feed that we're looking for, but we can probably check it while we're there anyway. So let's go ahead and move back to the first page. Okay, so if we continue down the line, just taking a look at these descriptions and seeing if any of them mention anything along the lines of ignition or battery voltage. If you look over here, you'll see TBAT3. That's actually for the battery temperature sensor, so we're going to skip that one. I'm just taking a look at these as I go down the line. And if you look right over here, you'll see we have 2 grounds, G102, on pins A22 and A23. So we have 2 main grounds right here. So I'm going to go ahead and highlight those 2 brown wires. And let's zoom out a little bit here. See where those ground wires come from. So if you look right here, you'll see the 2 brown wires go to this junction connector behind the IPU lid. And if you look over here, you'll see these brown wires are attached to a ground. And this ground is located on the left side of the engine. And that's going to be ground G102. And that's going to be one of the things that we need to check. So moving back over to the module. Again, we've located 2 of the main grounds. Let's just continue down the line here. And if you look over here, looks like we spotted one. It's labeled IG1. And that, I'm pretty sure, is going to be an ignition voltage feed. So let's go ahead and highlight that wire. And let me go ahead and deselect the other 2 so we don't get confused. Now let's follow this wire out and see where it goes to. If you follow it over here, you'll see it continues on the next page as number 11. Let's go ahead and move over to the next page. Number 11. And if we follow this up, you'll see that it gets its power from this fuse number 10, which is a 7.5 amp fuse. Now, what's real important about this fuse is that if you look here at the top, it says that it's only hot in on or start. So what that means is that when the key is in the off position, there's not going to be any power provided to this fuse. So that's real important to note, that the ignition has to be on in order for power to flow through this fuse number 10. So that's definitely one of the power feeds we're going to need to check at the computer. Now going back to the first page, again, we're definitely going to be checking this pin 29 IG1. Now if we continue down the line here, again, these T-BAT, those are going to be the temperature sensors for the battery. We continue down the line here, and I really don't see anything else describing anything that could be a main power or a ground. Now, just as a quick review, let's go ahead and highlight everything we're going to be checking. Again, we're going to be checking this IG1 on pin 29. We're going to be checking these two grounds on pin 22 and pin 23. Then we're going to be checking the ignition voltage feed on pin 2, also pin 3, and then also pin 4. So these are going to be the main powers and grounds that we're going to be checking at the computer module. Now the nice thing about this is that even though there's two connectors on this control module, all of the pins that we're dealing with are going to be on the connector labeled A. So if you look at where this separates here, everything up here is going to be connector A. So if you read the pin numbers, you'll see A29, and if you look down over here, you'll see connector B. So you'll see B1, B2, B3. So where this splits off, everything from this point up is connector A, and everything from this point down is connector B. So we're only going to be focused on connector A. Anyways, now that we have this knowledge, let's go ahead and move back to the vehicle. Let's locate this BCM, get a pin out for the connector, and check our main powers and grounds. All right, guys, so as you can see, I went ahead and I removed the back seat, the bottom and the top part, so that we can expose the high voltage battery, which is located right here behind the seat. Now there is a cover that has to be removed, this big cover here. There's about 9 or 10 bolts on there. And there's also this big switch right here that we have to switch off in order to deactivate the high voltage battery. I've already gone ahead and done that. Now let me see if I can give you guys an overview of everything that's located back here. Okay guys, so this is what it looks like from the inside of the vehicle. Again, this is hidden behind the back seat. And as you can see, there's plenty of components here. I'm going to try to do my best to try to explain to you how this thing is laid out. Now, before I do that, I should mention that there are some better videos on YouTube that go into much more detail about how this thing is set up. Because to be honest with you guys, I don't work on these very often. I had to do a little bit of a refresher in order to refresh my memory. And there were some videos on YouTube, specifically from a channel called Weber Auto. I'll link those videos in the description, but I'll tell you right now, those are the best videos on YouTube pertaining to this hybrid system on these Hondas. The instructor goes through every part of the system and how it works. So again, I'm just going to give you guys a basic overview, starting with the high voltage battery, which is located right over here on this side. This whole boxed area right here is going to be the high voltage battery. So inside of this thing, you're going to find a bunch of different cells that are tied in series together. And when they combine, they make somewhere between 150 to 160 volts. Now this high voltage battery is what's used to run the electric motor. It's also used to run the charging system and various other components as well. So again, as you guys know, this is a hybrid vehicle, and what we have under the hood is going to be an electric motor / generator that is sandwiched between the engine block and the transmission. Now I say it's a motor / generator because it does two different things. Whenever it's used to drive the vehicle, it's going to be considered an electric motor. And when the vehicle is coasting or braking, that electric motor is going to work like a generator in the sense that it's going to be backfeeding power to the high voltage battery. And that's how we charge up this high voltage battery. So again, under the hood, we have the electric motor / generator that's sandwiched between the engine block and the transmission. And that motor generator has 3 large cables attached to it. And these cables can be identified because they're the color orange. Now those 3 cables that run from the motor generator to the back of the vehicle attach themselves to a unit located behind this thing, not this unit, but right behind it, called the inverter converter. Now the job of this inverter converter is to basically run the electric motor by pulsing the 3-phase cables and generating an AC sine wave to drive the motor. And on the other hand, its other job is going to be to take the alternating current that's generated by the generator / electric motor and convert that into usable voltage to charge this hybrid battery. Now, in our case, we're not going to focus on that. What we're dealing with is a charging system problem. And because this vehicle is a hybrid, it does not use a conventional alternator. It uses something called a DC to DC converter, which is located right here. So let me briefly explain to you guys how this works. So again, if you look over here, we have the high voltage battery. Again, this thing produces between 150 and 160 volts. And if you look right over here, we have these two orange cables attached to the high voltage battery. One is a positive, one is a negative. And if you look at both of these cables, they connect directly to the DC to DC converter. Now, what's important to note is that both of these orange cables are carrying the full voltage of 150 to 160 volts. So the job of this DC to DC converter is to take that high voltage that goes into the DC to DC converter and drop it down to normal charging system voltage, which, as you guys already know, is normally somewhere between 13 to 14 volts. And if you look right down here, you'll see I've opened up this red cap here. This is going to be the positive terminal. This cable here runs from this DC to DC converter all the way to the battery that's located under the hood. And if you look at the other cable, there's going to be a ground right here, and that grounds directly to the chassis. So that's basically how the charging system works. Again, we don't have a conventional alternator. What we're having to do is take the high voltage from this high voltage battery, step it down to a usable 12 volt system charge, and use it to run all of the electronics, computers, and accessories on the vehicle. Now, the important thing to note is that in order for this DC to DC converter to do its job, it has to be controlled by the battery conditioning module. And that battery conditioning module is located right here. So essentially, this battery conditioning module is going to monitor the system voltage, it's going to monitor the load, and it's going to determine what the voltage output should be of this DC to DC converter. So of course, you guys can understand why, if we don't have communication with this BCM, this DC to DC converter cannot do its job and the charging system will not operate. Now, if you look at this BCM or battery control module, you'll see that we have two connectors. One up here is an orange connector, and you can see it goes directly to the high voltage battery. Now, what this connector is for, these are going to be the individual wires that go to the individual cells inside of this battery, and that's how we are able to look at the scan tool and monitor the voltages of the individual cells in this high voltage battery. And of course, we also have the battery temperature sensors and the battery current sensor. They also both connect to this connector here. Now, if you look down here, you'll see this other connector, and this one here is going to be where we will most likely find our main powers and grounds. So anyways, hopefully that makes sense to you guys. Let's go ahead and move on to doing our checks. All right, guys, so we're going to start by checking our ignition power feeds. It's going to be pins 2 and 3, both of these pink wires on this connector here. So we're going to start by back probing pin number 2 right there. Now I'm just going to reach over and turn the ignition on. Let's see if I can do this. Okay, the ignition is on. Go ahead and move back here. I've got my power probe connected to the battery. We're just going to be using this like a voltmeter. So I'm going to go ahead and touch the back of the back probe, see if we have power. And as you can see, it looks like we have a ground. So we don't have power there. Now, seeing a ground doesn't necessarily mean that there's a short to ground. It could be that the voltage from this thing is just backfeeding through the relay circuit. So we're going to go ahead and just keep that in mind. I'm going to move over to pin number 3, which is our other pink wire, our second ignition voltage feed. I'm going to touch this. And as you can see, we're showing the same thing. So we don't have power on either of those two ignition circuits. That's definitely going to be a problem there. Okay, so if you guys recall from the wiring diagram, you'll know that these two ignition power feeds get their power from the MCM relays, which are both located right here. We have relay number 1 and number 2. I'm not sure which one is 1 or number 2, but I think this is probably the first place we should check. Let me go ahead and see if I can pull these relays out. Looks like there's a clip here, and I think there's a clip on the back side. So let me get these relays out and let's do some quick checks. Okay, guys, so I've got the relays unclipped, and you can see we have both of the relays here and both of the connectors. Really easy access so we can do our checks. Now, if we move back to the wiring diagram, if you guys recall, we had MCM relay number 1 and MCM relay number 2. And of course, number 1 provided the power for the number 2 relay. So what we're going to want to concentrate on is going to be the MCM relay number 1. And again, we have the 2 green wires. That's going to be our power feed into the relay. We have our pink wire, which is the power feed out. to both of the ignition feeds at the BCM. And then of course we have this orange wire, which is the control wire. So I think first things first, let's go ahead and check to make sure that we have power on both of these green and yellow wires on this MCM1 relay. So if we look at it here, we can easily spot it. It's going to be these two green and yellow wires. Let me go ahead and get my back probe tool and back probe these wires. All right, so I'm just going to stick this in there. And we're going to see if we have power. I've got my power probe right here. We're going to touch it. And as you can see, we don't have any power on that. We can probably check the other one, even though they're both a shared power feed. We can see if we have anything there. And we're showing the same thing. That's not a power, that's a ground. So I'm pretty sure that we checked these wires. We don't have power. We're probably not going to have power on the pink wire. I can already guarantee you that. It's pretty obvious what we need to do next. We need to backtrace this green and yellow wire, follow it back to the fuse box, and maybe start by checking the fuse. Now, if we look at the computer once again, you'll see that the fuse box, where this fuse is located, is going to be auxiliary under hood fuse relay box, left side of engine compartment. We're going to be looking for fuse number 62. It's a 7.5 amp fuse. So let's move under the hood and check it. Okay guys, so I can't make this stuff up. Let me show you what I just found. So I came under the hood to look for the fuse box, and I saw this one there, obviously. And I looked down here and I saw another one, and it was pretty dirty. I couldn't really read it, so I stuck my hand in here to wipe the top of it. And when I stuck my hand down here, I noticed that this wire here was really loose. Now, I don't know if that's our problem, but this is not a good sign, because what if these are the wires that feed to the fuse box? And I mean, if they are, then I guess I got pretty lucky, because it's probably just a loose wire. So again, I'm not really sure. I'm just gonna go ahead and tighten this nut up, and then let's double check our checks. Okay guys, so let's try that again. We have our relay here. Let me take my back probe and let's stick it into the green wire, green and yellow wire. Now let's take our power probe and let's check it. No way. Okay guys, so as you can see, we have system voltage on that green wire. Let's check the BCM. We still have our back probe in here on the ignition power feed. Let's go ahead and check it. Check that out. We have system voltage now. Let's see if we can communicate with this thing. Okay guys, so I've got the scan tool over here. I'm gonna go ahead and turn the ignition on. And the first thing that I noticed that I really like is that our D is no longer blinking. So that's a good indication that we may have fixed our problem. Now, I'm just gonna go ahead and start this thing up. Okay, now that we've got this thing running, let me grab the scan tool and let's see what our system voltage is. If we look up here, you can see we're showing about 12.8 volts. Now our battery was really low, so I'm pretty sure it's gonna take some time for it to get up to charging system voltage. Let's go ahead and move on to seeing if we can communicate with the IMA control module, or the BCM. Okay guys, so I noticed that the charging system voltage was not charging, and then it occurred to me that I forgot to flick the switch on for the high voltage battery. So let me move back there and turn it back on. Okay, so in order to turn this back on, you need to push this little safety button and then flick the switch up. And of course, now that this thing is powered up, be careful not to touch any of the cables or anything here. So now that we have that done, let's go ahead and start the vehicle back up. Okay guys, so as you can see now, we have charging system voltage. I'm sorry, I forgot to turn the switch back on for the high voltage battery, but now that it's reconnected, everything's working properly. So let's go ahead and see if we can communicate. We're gonna go into the IMA module, go to live data, and bam, we have communication. Okay guys, so now we can go through this data, and we could probably find the data pins for the individual cells or the packs inside of the high voltage battery. You can see they're located right here. Battery voltage module 1 through 9, and there's more. I believe there's a total of 12 or 13. And as you can see, they're all charging at about 16 volts. All of these look good. Let me scroll down. So it looks like we have a total of 11, and as you can see, they're about 16 volts, so everything looks good so far. Okay guys, so from here, I'm just gonna go ahead and clear all of the codes. I'm gonna take the vehicle for a test drive, an extended test drive. I'm gonna make sure that the vehicle does not stall, that we don't have any charging system problems, and if everything's good, we can go ahead and ship the vehicle. Anyways guys, I'm gonna go ahead and end off the video here. Now, I did take the vehicle out for an extensive test drive, somewhere around 45 minutes, and the vehicle did not stall on me. Also, the charging system stayed charging, so that was a really good sign. So as far as I'm concerned, the vehicle is fixed. Now, I know a lot of you guys are probably wondering why that cable was left loose. And to be honest with you guys, I don't know. I know the customer bought it, and ever since he got the vehicle, he's been having problems with it. It does look like at some certain point in time, they replaced that front battery. And it is possible that whenever they went to install that battery, they simply forgot to tighten down that wire. So anyways, guys, like I always say, thank you for watching the video. I hope you found it useful. I hope you found it informational. If you did, make sure to give it a thumbs up. If you haven't done so already, please subscribe to the channel. Make sure you hit that notification bell, and I'll see you guys in the next one. Thanks.